First of all, I want to start with saying I am no expert in creating immersive um, experiences, but I have been fortunate enough to work with amazing me use these experiences in my field and improve things in my field. So what I'm gonna do today is gonna tell you my field of work and why these immersive experiences are giving me excellent tools to improve different aspects of my job. So I'm not gonna go through the introduction because Todd already did that. And I'm gonna start with the construction domain of my field of work. You all have seen construction job sites around you. They are highly dynamic. They are changing every minute. And there are a number of subcontractors and different teams working together at the same time on the same project. And that means information is being updated every minute, but those updates are not getting their way into the platform that we have for information. And also we have different digital sources for the information we are creating throughout a construction project, some of which including the blueprint, 2D blueprints, 3D models, schedules, change orders, instructions, different types of information that are created before the project starts and get updated throughout the life cycle of the project. And because of that ever-changing kind of environment, any mistake can be very costly for the owner and also for the workers. It can cause deaths, fatalities, and incidents just because people are not receiving the information that they need. In addition to that, right now we are at a crisis level in terms of having access to skilled workers. So imagine all of that, and now let's imagine the future, and I would say even near future. We all have heard of the fourth industrial revolution, Industry 4.0, and it's finding its way slowly into the construction industry, where we imagine a digital technological environment where everything is connected to everything else. In such an environment, we started using different technologies, including Internet of Things sensors, robots, and I'm considering new unmanned aerial vehicles and unmanned ground vehicles, as well as automated equipment as robots as well. I hope robotic friends are not gonna pick on that. So these are all expected to help us improve our processes, automate our processes, and collect some kind of information from the job site, or perform tasks that usually are not easy to be done by the workers. We are also having a smart material, like let's say smart concrete, that can define if it has gained the strength that it has been designed to. And also we are talking about having information management, proper information management through building information modeling. So we can kind of manage all this data that we are collecting from the construction job site. But in between all that, what we are ignoring the most are the workers. Unless we are imagining that we are not going to have any workers and they are going to be completely replaced with the robots or all the technologies that we are introducing to the environment, we have to do something for them as well. And the reason I'm saying that is we are changing the landscape of their work. Everything around them is changing. And everything is being augmented, but we are not thinking about augmenting the capabilities of workers as well. So I am calling that augmented capability worker the worker 4.0. That is a worker that can make use of all the information and technologies that are collected from the construction job site and is at the same level of intelligence and analysis of data that everything else in the job site is. So now this worker 4.0, I just mentioned, there are a lot of technologies around him. He is seeing drones and cameras and sensors collecting data from the materials and all the processes around him. We also are giving them different devices. We are giving them AR glasses. We are giving them smart watches to collect their health information. We are mounting EEGs to collect their physiological sensors. But unless we consider their characteristics, none of these technologies that they are surrounded with is going to work in their benefit. And to help them with all of that, there are different things that we have to consider. First is how these technologies can help us know how skilled they are and maybe assign their tasks based on their skill level. How we can realize if they are fatigued or not, or maybe release them from some activities or lower their loads for the day. How we can realize how motivated they are and maybe design approaches that can motivate them more. In addition to that, we need to have a sense of their performance and know, again, how using these technologies is not going to distract them from what they're doing. And instead of that, it is improving their performance. So when we do that, when we consider all of that, the outcomes are going to be improving their safety, improving or preparing them not only to use the technologies, but to work safer in the job site and also improving their productivity. So that's where my work lies in. I'm trying to use different technologies to improve safety training and productivity of current and future construction workers. And for that, I am working on different projects. I'm designing different technologies. I'm working on a smart wearable, virtual voice assistant, as well as immersive technologies to improve all these three aspects. And for the sake of this meeting, I'm going to present two of my projects on using VR, group SVR, to improve safety of highway construction workers, and also intelligent AR for the future of construction workers. I'm gonna start with the VR project. And what is important in my field when using these immersive experiences is which one is going to fit what situation. For example, in which situation you can cut the person out of the reality and use virtual reality. For sure, we cannot use that on a real job site when they're doing their job, because that is not going to be in their benefit. So depending on the application, the kind of immersive experience you're going to create for them is going to be different. For example, what is needed, what is essential to keep workers safe is training, proper safety training. And to have a proper safety training, it should be well designed. It should be the same as anything else that you want to teach anyone. It should be engaging. It should be based on the experience of the learners, and it should be related to the context of the work that they're doing. But, well, this is the kind of training that workers are currently receiving before doing their job. Because, and that's understandable, because of the number of trainees in a classroom and the limited number of instructors that we have, they cannot have more engaging methods, or the instructor will not have the chance to take the workers into a job site and show them real hazards or real experiences they are going to be exposed to later on the job site. And we all know, we have all taken the Title IX training. This kind of training is boring and it's not teaching you anything because you are not actively involved in training. So we thought virtual reality can help with that because it can create a more active learning experience for the workers. They are in a training phase, so they're not on a job site, so it's okay if they are not, if they are cut out of the environment. But one thing about the head-mounted display was that the experience would have become a solitary experience. And we have a group of trainees in a classroom which want to be trained. And also that collective engagement in learning is going to be in their benefit. So we thought about also when they are wearing the headset, that is going to also cut them from the instructor. So we need to have we have to design a training that complements the current trainings by having the instructor in the loop and creating a group-based experience for the trainees. So we designed, with the help of Todd, we designed this situated learning scenario-based training that has the instructor in the loop. It is group-based, so it is for the whole group of students or trainees in a classroom. It is scalable, it can be used in any classroom, and it is based on the needs of the people in the class. So the instructor has the ability to improvise on different scenarios based on the needs he sees in his trainees. So what we did, we collected data from a real highway work zone and then translated it into a VR environment. And we tried to see, depending on different locations on the job site, placing the worker, what kind of hazard they are going to be exposed to. And that helps the instructor try to walk the workers through that experience and makes them understand the hazard or the risk they are going to be exposed to later on when they are on a job site. The learners in such an environment will have the opportunity to recognize the hazard in different situations, different environments, different conditions, then to evaluate the severity of the hazard and provide control strategies for each of the hazards they can recognize. And you can see, we are considering different scenes in the job site in different locations because depending on the location the worker is placed in, he or she is going to be exposed to different types of hazards. And those hazards are even different when they are in the same location, but let's say they are there during the day versus during the night where they do not have much visibility, they cannot see well. So all of that is going to help the construction workers be prepared by being exposed to realistic scenarios before they actually put a foot on the job site. And also that experience is safe for them. They see the hazard, they are so close to the traffic, but it is all not real. So they are not becoming unsafe. So as the first step to kind of experiment with this method, this training, we used the 360 projection at the cyclorama in the cube to project the scenarios and see how it's going to help us create the environment that we were looking for. I'm muting it because it has our conversation.
All right.
And you can see, although it is virtual, it's not real. You feel yourself so close to the traffic. And that's exactly the experience that the workers need to have. They have to sense how each of their actions is going to turn into when they are in a real job site. As the next step, I'm working with Todd and also Pilar and many other people to kind of move that on the classroom and have one person wearing the VR headset and the instructor being able to share that environment, share that experience with the whole class. So they are going to learn through collective engagement in the scenario. That is for VR. And again, because the training happens before they set foot on the job site. So we can place them in a location that is not real. We can distract them. But then when they are on the job site, we do not have that option. So we are gonna need to use another immersive experience for them. And that's where we started thinking about using intelligent AR, which is going to be a bit futuristic. Right now, we have some AR applications in construction, especially used for design when you want to see the final product, the final project, when you are designing and see if it's satisfying the requirements or if there are any clashes that you haven't accounted for before. But the problem with current approaches to use of AR in construction is they are providing a one size fits all or fits everything. Which we all know when we are giving a human something, you cannot use a one size fits all kind of approach because people are different, situations are different. And based on that, the experience that different people are going to have with the same thing is going to be different. And especially going back to the dynamic environment that we have in construction, the context of use matters. So we started thinking about how AR in construction can become more intelligent. And to become more intelligent, it needs to consider a lot more factors. It needs to consider characteristics of the workers. It needs to consider the work they are doing. It needs to be able to recognize, detect the work they are doing. And also it should give us a sense, or it should have a sense of what is going on in the environment. Unless we have all of that, the information that is going to convey the worker is not going to be of much use. So the intelligent AR that we are envisioning leverages the current headset sensors to get the context of the job site, get the location of the workers, and based on that, connected to the information sources. Let's say connecting their location with their schedule, it is going to recognize where the person is and what he's working on. We are using, or we are going to use computer vision, machine learning, and artificial intelligence model to process how to use the information, the raw information that is collected. And we are going to use that to provide the workers with the right information at the right time and right place and in the right level of detail that is going to be enough for them to do their job and not too much to distract them from anything that they're working on. So let's take a look at that from a scenario. And I know that Doug and Joe had presented that last week. So let's say we have a welder working on a steel job in a very big project, on a very big commercial project. So the intelligent AR that we are envisioning is going to recognize when he arrives on site at wears the headset, the AR system is going to recognize that he's tired. So maybe it can send a notification to the supervisor to change the activities for the day, but at the same time, it can be more rigorous in sending alarm in terms of safety. Also, then it recognizes what activity the worker is set to do and helps him or her in doing the task through showing step-by-step 3D visuals that shows the steps that maybe he needs to do or maybe he missed. And then also after he finishes, it can detect the completion of the task and send that information to the systems that we have, the information system. The same as the other project, we did a short experiment. The capstone students from Doc's class worked on developing an AR mock-up, AR experience for the still connection that we developed for our voice assistant project, and tried a step-by-step visual instruction-based scenario using the AR. So in reality, in the job site, what they receive as instruction is the 2D drawing on the lower left that you see. This is what they receive, and they are supposed to work based on those information. And imagine if they are not skilled enough, if they are a new worker or a worker that has been moving from a different sector to that sector, how hard it's going to be for them to understand everything or grasp everything at the first class. So having this audio or visual kind of help or instruction is going to be very helpful for them. And here is a video of the experience. So the students created the experience and kind of instructed the participants on where each of the materials were, what they needed to do. Okay. So it shows where to pick up the material, where they have to place it, what is the steps they have to go through to complete it. And at the end, it's going to tell them that the task is completed. So that simple example can show how providing that kind of on-the-spot information to workers, especially, again, newer workers, can be helpful in upskilling them and getting them on the job site sooner than it usually takes for them to get on the job site and get going on the job site. So again, I'm no expert in developing any of these experiences, but I am so happy I got to work with people who helped me create those experiences for the workers. And that would be my presentation. I would be happy to hear any questions or comments you may have.